if you ever go into farming or if you ever have to, I don't know, take integrated 3 or 4, if you aren't already doing that, you have a farmer with this much fencing and wants to enclose this rectangular area and then divide it into 4 pens with fencing parallel to one side of the rectangle. It's making these nice little right triangle or right angles. What's the largest possible area for the 4 pets? Well, let's really think about this because you have these dividers. How many dividers do you have? You have 5. So you have 5 dividers. I'll just start this wordy. So 5 dividers. And then you have 2 versions of this width. So 5 dividers, 2 things of the width should be equal to 950 if we're trying to get the largest possible total area of the 4 pens. So we can now make an equation that just talks about the length that's being used. We say that the dividers are x based off of what was given to us. And we have 2 versions of the width, not like the classwork where we had to just have 1 version of that width. And so this is an equation we can use. So this is good for starters. I'll call this equation 1. But you need a second equation now, which talks about that potential area. And luckily, this is a rectangle. This is light work. This is just base times height. So x times y. And that'll kick us an area. And so it's now up to you with which dimension you want to get. Do you want to get the length of the divider or the length of the width? You can do either one, choose your fate. But now what you want to do is solve for x or y in equation 1. So I'm going to personally solve for y. So if you do that, you're going to have 950 deducting 5x and then dividing all of that by 2. So this now equals a form of y. Again, it's based off of this equation. And so the fourth thing you want to do, plug in for y in equation or step 2. So now if you rewrite this, you still have x, but now you have to multiply that with 950 minus 5x over 2. And so this is helpful because remember, this was x, this was y, and this was supposed to kick us an area. And if we sketch this and graph it, there is going to be a potential max area that's produced, and it's going to work with all the dimensions and distribute those evenly to x and evenly for the y's. So I'm going to take this to a graph and we'll see what pops up next. So you could probably get away with doing a quick sketch of this on your own, especially if you look at this and notice that you have an x-intercept at 0 and 190. And again, that's based off of solving 950 minus 5x when it equals 0, which in this case, x is going to have to equal 190. This is kind of based off of integrated 2 when you had intercept form. Even though this doesn't look super clean, it's still going to produce an x-intercept of 190. So this means that your middle between 0 and 190, so the average of the two, and they occur at 95. And so let's take a quick journey. Let's find that. We see, boom, it's at 95. Good. So this is saying that if your height is 95, and I'll summarize this here, height x equals 95. This is going to produce a max area of 22,562.5. Feet squared. Yeah. Feet. Yeah. Feet squared. Good. Good. All right. And so you could have done this again with a quick sketch, but the key idea is that you would have and x-intercepts at 0. And I'll do one pair. And buck 90, 0. So the halfway point between the two, like we said, is 95. So it occurs when x is 95. Hope this helps for this one. All right, I've been getting some questions on this. I love questions. They keep me busy. They also keep me employed. You are trying to push this rectangle into a parabola that's given with this equation, 9 minus x squared. If you saw this and said, oh, this kind of looks like a negative x squared plus 9, and then said that that kind of looks like a negative x squared minus 9 with a difference of squares. If you saw that and you're feeling pretty confident saying that this is now 3, 0, and this is negative 3, 0, kudos to you. But let's see, will that help us? Let's find out. So you know that you're trying to find this area, this potential rectangle where it can be as maxed out as possible. So we don't know if that's going to be super wide. We don't know if it's going to go way up north, and maybe that is the best area. Of course, staying in that zone of being under it, we don't know. However, we do know that at least from here to here, this is going to be two versions of x. Because if this is x0, this would have to be negative x0. And the sum of those two distances, if this is x, this means this is 2x. Okay, capiche? So this would have a respective height of y. And so luckily we don't have to worry about like the footage of anything here. We at least can say that the area is going to be 2x times y, and that's the area of the rectangle. And this is going to kind of be similar to the previous setups where you now want to plug in something. And although this says f of x equals this, isn't f of x just another way to say y equals? And can we now push all of this into here and say that the area can be rewritten as 2x times the quantity of 9 minus x squared? And if we want to distribute this because we're feeling fancy, we could. Getting you this. And doesn't that look like something that can be graphed out? Let's do that. All right, so we're here on the set of graphing this negative cubic function of, yeah, you could also write it as negative 2x cubed plus 18x. You could do that. Maybe that's what you choose to do. We see it's a cubic function. We only really want to play around with the positive domain, which is from 0 to 3. And we see that what's produced as the max is going to be this 1.732, comma 20.785. So why is that important? Well, we're able to say that when x is 1.732, meaning that from 0 to 1.732, that's the ideal half of that, of the rectangle, it's going to produce an area of 20.875. Yeah. And they don't give us units, so that's just going to be units squared. So why is that helpful? I can do a quick sketch when I jump back. So I'll do that. So like we were saying, this rectangle is going to go from here to here. We know that the middle is this y-axis, and we know that the extent in the one direction is going to be to 1.732. And that down here, this is negative 1.732. So this total sum is two versions, 1.732, which at a quick glance, I have the power, so I'll do that. 2 times 1.732 gets you 3.464. Units. And just for closure, let's see how high will this thing kick up. Well, we know that the area is going to be producing 20.785. So we can do 20.785. We'll divide that by the 3.464. And that's going to be approximately 6. Okay, so what's the maximum possible area of the rectangle? It's going to be this 6 times this 3.464. Like we said, it was approximately 20.785. So your max area is going to be 20.785 units squared. Capiche? Sound good? I like this problem. I think it's cool. I think it's a good one. Ties in a lot. Totally capable of it.